Okay, we will start with module number 3. Total power system is divided into 3 sections, like we discussed in the introduction. There is generation, then transmission, then distribution. Now we are going to that third part. We finished generation, finished transmission, and going to the third important section, that is distribution of electrical energy. Between generation and transmission, there is a substation which will step up voltage to higher voltage. So transmission happens at higher voltage. We study why it is going for higher voltage and how to select voltage, how to select the parameters of transmission line. And we did some design of transmission line, and finally some parameters determine the quality of transmission, that is voltage regulation and efficiency. Now, while we move to the distribution, in between transmission and distribution, there is substation, because transmission is from the power plant up to the substation near the load center. So substation actually comes in between. Inshallah, we will study about substation in this module number 3. Beginning of module number 3, we will give an introduction about distribution. Then we will start with substation. We will start with what is distribution. In transmission, we are taking power from the power plants and supplying to a substation near the load center. This is a bulk amount of energy. For example, if it is load center is a city, so all the power required for that city will be, maybe not all, anyway, a huge amount of power required for that city will be taken from a power plant or many power plants, and this will be connected to a main substation in that city or in that area of that city. From that substation onwards, the distribution happens. Up to that, it will be not one line, but one line means a group of lines. Like you see when you travel, you will see lot of transmission lines crossing the highway. All these together, you can call it as one line, which is going from one power plant to a power substation. And once it reaches that power substation, there onwards, distribution starts. Now one set of lines will be going to one part of the city, another set will be going to another part of city. Like this energy is distributed to different parts of the city or different parts of the load center. That is actually the job of power distribution system. The electrical energy is supplied to the consumers by the power distribution system. So from where it gets power? It takes power from the bulk source and distribute or deliver to the consumer with some condition at required voltage and proper frequency. There should not be change in frequency. As you know, frequency must be 60, and the voltage not constant now. Different consumers are there. Depending on the size of the consumer, they may require at different voltages. Not any voltage, there are standard voltages, as you know, but from that standard voltages, different consumers need at different voltages. So the job of distribution system is to take that power from the bulk source, that is a power plant or a power substation. As we discussed in previous lecture, transmission is not a must. If the power plant is near the city, there is no transmission. Then the distribution system will start directly from power plant. Example is our Yambu. Here, distribution starts from the power plant. So from there, it take the power from the source, maybe a power plant or a substation, and distribute or deliver to the consumer at required voltage and frequency. So how to change to this required voltage? By stepping down the voltage with the help of substations. For that, we have distribution substations and distribution transformers, and there will be many substations which will step down voltage into different voltage levels required by the consumer. Total distribution system is divided into 6 sections. It happens in 6 levels. The first level is sub-transmission circuit. We have the bulk power source. This can be a power plant or a power substation. For example, our case, it is Marafiq, the power plant. From there, some lines starts. That line starting from that power plant or power substation is called sub-transmission circuit. It will be at higher voltage like 110 kilovolt. High voltage, not extra high voltage, it is very high voltage 110 kilovolt. Normally some places it is 66 kV also. Normally it is 110 kilovolt. This line first level is called sub transmission. This sub transmission circuit will end at a substation which is called distribution substations. The distribution substation will be a substation which is located at different parts of the city. Like for our Royal Commission area, we have 7 substations like that. One of them is near your that new housing. There is a gray building. That is a substation. That distribution substation will take this sub transmission line. There is a set of transformers which will step down this high voltage to a distribution voltage, and then it will be given to the primary feeders. Primary feeders are the lines going to each and every small areas of the city. Like for example, one primary feeder will be coming to the college. One primary feeder will be going to Al Nahda. One primary feeder will be, one or more, maybe sometimes if it is a big area, more than one line may go. One will be going to Al Subh. One will be going to Ain Al Nawa. Like this, under that distribution substation, the area will be divided into small areas, small districts, or even less than that. This locality, like we call that Al Nahda, Al Subh, like this type of small areas. 1 or 2 lines will be going to those areas. These are the primary feeders. That will end at distribution transformers. Distribution transformers are, again, it is a substation, but there is no big devices. There will be a simple transformer and few switching devices and protective devices. These are the one which you see in your locality. There will be a compound, in a small half wall type compound. Inside that you will see a green box. Did you see that in your area?
Yes.
Yeah, this is the distribution transformer. It will be in a small compound or in a wall. Inside a square wall, there will be a green box with a transformer. That is the distribution transformer. From there, so this is the distribution transformer. From there, many lines will start. They are called secondary circuits, or simply we call secondaries. These secondaries will be passing through or nearby the roads, passing through nearby your houses. This will pass through every house, not connected to the house, but in front of the house, through the overhead small poles, or in our area it is underground. So underground, through the sides of the road, there is a trench. Through that trench, these cables are passing. That is the secondary. It will be at our voltage 110, 220 or 208, that lower voltage. And from that secondary, we will take a connection for our house. That connection taken for each consumer is called service connections. Like this, there are 6 levels starting from Marafiq until your home. Starting from the substation, in some cases it may be substation. If there is no transmission, it will be a power plant itself. 6 levels. First 2 cases are transformers, other are lines. These are the typical structure of a distribution system. Each and every, what are they, already I explained. So first one is sub transmission circuit. It starts from that bulk power source, ends at distribution substation, and the voltage can be 33 kV, 69, 132 kV, maximum up to 132 kilovolt. What we use here is 110 kilovolt. Distribution substation is a substation which is for serving a area of a city. So total city will be divided into 4 or 5 or maybe 7, 8, some small number of areas. That's many distribution substation will be in a big city. If it is a small city, maybe only one distribution substation may be there. From there, this area will be divided into different small areas. Each area will be, each sub area will be, each subdivision is supplied by primary distribution feeder or a simply primary feeder. Normally this use voltages, lower voltages like 11 kilovolt or 13.8 kilovolt. We use 13 kilovolt normally. In our area it is underground cable, but in some villages or such areas you can say overhead circuits for this. Then we have this distribution transformer. They will step down into utilization voltage which is coming to our house, and that line which is coming nearby our house is called secondary distribution line, and the connection for each consumer is called service connection. And each service connection will be connected to your house through a meter for measuring the amount of power you calculate. Here also secondary distribution also may be a cable or overhead through the poles. Now coming to the last part of the introduction, that is what are the qualities required for a distribution system. Lot of a distribution system to be good, there are a lot of qualities required, but there are 5 important parameters used for the measurement of effectiveness of a distribution system. First one, like in transmission, here also voltage regulation is really important. Voltage regulation in transmission, like happening in transmission, in distribution also voltage regulation will happen, because distribution it will be in a small area, but it will be at a lower voltage. For current will be high and the size of the conductor will be less, therefore the resistance of the conductor will be high, therefore there is chance for higher voltage regulation in the case of distribution system than transmission system. So you have to be very careful about designing a distribution system to provide a better, that is a lower value of voltage regulation. So if a system have a good voltage regulation, it is called a good distribution system. Actually, our country, our voltage regulation is one of the best. We don't feel much difference in voltages, but if you go to some countries where power generation is less, you can see this big difference in voltage voltage. That is big value of voltage regulation happening where this power production is less than required. Second is service continuity. Service continuity means supplying power for 24 hours continuously. Of course, here we get it rarely, very rarely we miss power. So the distribution system must have sufficient facilities to provide power continuously without any disturbance. This is service continuity. So if a system is able to provide power 24-hour, every day, every month, every year without any disturbance, then it is called service continuity. Then flexibility. Flexibility is actually related to stability. Flexibility means you must be able to add any load to this. Suddenly, if you add some load to this distribution system should not damage or should not change voltage or frequency. Without any change in voltage, frequency, or operation of distribution system, you must be able to add more load or suddenly turn off some load. This turning on and off of adding or reducing load should not affect operation of a distribution system. Then it is called a flexible distribution system. Efficiency, of course, is an important part. Because of the resistance of the distribution line, there will be I square R losses and also many other losses. So the design of the distribution system must be such a way that losses are minimum, so that efficiency must be higher. So these are the four important technical parameters related to effectiveness of distribution system. And finally, economically, there is an important term that is always cost. You must be able to supply power at the lowest possible cost without compromising the previous technical things, efficiency or voltage regulation or service continuity. You have to use better devices, better number of transformers, good number of transformers, but still you have to you must be you means that power distribution system must be able to supply power at a considerable cost or lowest cost possible. So effectiveness of a distribution system is measured in terms of cost, efficiency, flexibility, service continuity, and voltage regulation. So this is all about